Welcome to this video about matrices and vectors. These concepts go hand in hand, and so we'll be talking about both of them and different things you can do with them, like addition, subtraction, and multiplication. So anyways, we'll just start with matrices, and the first matrix I'm going to write will be this one right here. And this is what it will look like. So this is a matrix, and each matrix or vector has a proportion. And when finding this proportion, you look at the amount of numbers in a column, and a column is just the vertical row. I don't want to use the word row, but the vertical arrangement of numbers you have. So the column would be 3 numbers, and then you look at the arrangement of numbers you have in a row, which is just the horizontal arrangement of numbers, and that's also 3. And a 3 by 3 matrix is easier to see because each side has the same amount of numbers on it. But that is how you find proportions of a matrix or vector. So this is a 3 by 3 matrix. Now let's go ahead and actually write a 2 by 3. So we have some variety. And as you can see, the column comes first. So there would be 2 numbers in each column. So 6 and 1. And there will be 3, excuse me, there will be 3 numbers in each of these rows. So 3, 4, 24, -9, and 8 to finish that off. So that is what a 2 by 3 matrix looks like. Now we can come to vectors, and the important thing about a vector is that it only is allowed to have either one column or one row. So they're pretty much just small matrices. So the first one will be a 1 by 3, and then I'll show you a 3 by 1. So a 1 by 3 is as simple as having one number in each of the columns, and there will be 3 columns because there will be 3 numbers in one row. So we have 1, 0, 2. So one of these numbers, one number in each column, and then 3 in the one row. So this is just one row. The next is a 3 by 1, so it'll just be one column, but 3 numbers in each row of 1. So 2, -8, 7. So 3 numbers in this, and then 1 in each of these rows. So for addition and subtraction, we can take these different matrices and vectors and combine them where it is allowed to create different problems and equations. So for addition and subtraction, the important thing is that whatever matrices or vectors you are adding or subtracting, both of the two have to have the same proportions. So just say we did a 3 by 3 and a 3 by 3. And we were adding them. Oh, I'm so sorry. I made this the wrong color. I don't want that to be confusing. Quickly change that. So this is a 3 by 3, and this is also a 3 by 3. And that's the only reason it'll work, because in this problem, the first number in this matrix will have to be added by the first number in this matrix. So just say this would be 1 and this would be 2. In your resultant, you'd also have a 3 by 3 because it has to be that, and it would be 3 for your first number. So your starting proportions have to be the same as each other, and your resultant will be the same because you are just combining the two matrices. So for multiplication, we can do it a slightly different way than addition and subtraction. But the biggest rule is that whatever matrices or vectors you are multiplying, the proportions have to be the same on their inside number. And that sounds confusing, but just say we had a 3 by 2 and a 2 by 4. You know this would work because this is a 2 and this is a 2. And your resultant would actually be these two numbers. Your resultant would be 3 by 4. And now, if you have a 1 by 3 and a 3 by 1, it would work the same way because these would be the same numbers, and your resultant would actually just be a 1 by 1 number. So that is how multiplication works. Now let's do some practice. Let's do addition and subtraction. So to start, I'm going to do two 3 by 3s, 2 by 3 matrices. So 1, 0, 2, 2, negative 1, 3, 4, 8, 10. And let's add second, 2, 3, 5, 7, 9, negative 2, 1, 0, 8. So these are both 3 by 3. To solve this, like I said, you just take your first number in each matrix and combine them. So 2 plus 1, or 1 plus 2, would be 3. 0 plus 3 would be 3. And then 2 plus 5 would be 7. And that's the same for every single number in these matrices. So 2 plus 7 would be 9. Negative 1 plus 9 would be 8. And 3 plus negative 2 would be 3 minus 2. So that'd just be 1. 4 plus 1 would be 5. 8 plus 0 would be 8. And 10 plus 8 would be 18. As you can see, that's the same proportion as these two. So 3 by 3. You just combine the numbers. So for subtraction, let's do 2 by 3s. That would be, let's say, 8, 2, negative 1, 4, 10, 5. Subtracting 1, negative 3, 4, 2, 7, 3. So you do the exact same thing as we did on the addition, but it would just be subtraction. So 8 minus 1 would be 7. 2 minus a negative 3 would change that to addition, so that would be 5. 2 plus 3 is 5. Negative 1 minus 4 would be negative 5. 4 minus 2 would be 2. 10 minus 7 would be 3, and 5 minus 3 would be 2. As you can see, that is also a 2 by 3. So these are pretty simple. Let's now go on to multiplication, which is slightly more difficult, but not too bad. So for multiplication, like I explained, the numbers in your proportions have to be the same on the inside. And then these numbers are the resultant. So let's start to better show this. Let's do a 1 by 3 and a 3 by 2. I'll make these pretty big. Let's go. A 1 by 3 would be 1, 2, 0 times a 3 by 2. Be 2, 4, 6, 3, 10, and -2. So that is a 1 by 3, and that is a 3 by 2. So your resultant will be a 1 by 2. And again, we start by taking this row and multiplying it by this column. So 1 times 2 plus 2 times 6 plus 0 times 10 would be the first number. And then we have 1 times 4 plus 2 times 3 plus 0 times -2 would be the second number. Made this box really large, but that was in order to help show you. So 1 times 2 would be 2, and then you'd add 2 times 6 would be 12, then you would add 0 times 10 would be 0. Then you have 4 plus 6 plus 0. Now you'd add these. 2 plus 12 plus 0 would be 14. And you have 4 plus 6 plus 0 would be 10. And your resultant would be that 1 by 2, which is 14, 10. And you don't have to put that comma. And that is your answer. And that works for larger matrices and smaller ones, but you just have to make sure that these numbers are the same.